Hi, I'm Yuhao, and this time I want to demo the pattern H in the final project. And yeah, before this, I need to show the whole pattern. It should actually print out like this one. And this code here actually demonstrates how I draw the repeated pattern H with 6 helper functions and a main function. Yeah, and there are 2 basic helper function and 3 advanced helper function and a final helper function. And actually, the final helper function is to combine the previous one, and each class of helper function are built on the previous class helper function. And there are actually well, so let's look at on this. The Let's look at on the construction structure. So first of all, this is the whole pattern, and the whole pattern is actually consists of like this repeated patterns. And it's draw like this, from here to here to here to here to here, da 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 da. And well, each repeated pattern actually constructed by 2 layers. One is a square layer, the other is a pattern layer, I call. And the first layer is little square layer. It's actually draw like this, from here to here to here, and all the way down through. And layer 2 is consists of like same procedure as layer 1, but yeah, it consists of like this pattern. I call it the single pattern. And actually, each single pattern is consists of like 4 parts of basic pattern by rotating each basic pattern. And now I just trying to emphasize on my code. So first of all, import turtle, of course. Define draw basic pattern. First of all, like task size, color. Task is handle, size is a basic is the size of the basic pattern, and color, yeah. And I will use the same kind of like arguments in the next following 5 helper function. And yeah, this is just trying to draw the basic pattern, and because of this this basic pattern is actually called axis, so I use a for I in range of 2 by just simplifying my program. And draw basic square, and basic square is this one. It's a little basic square, and it is really easy to draw. And draw single pattern. So the important part of the draw single pattern function is test right by 90. So I can rotate each the starting angle of each pattern, so I can get a final pattern like this. Draw repeated squares is this one. Draw these layers, and here, actually in the real one, it's a 4 by 4 square in the final pattern, so I use for I in range of 4, for j in range of 4, and here move task forward this, I need to move to the next column position of the basic pattern, like basic square, and this one is recover the column position of the first basic square in each row. And here I move to the next row position, so it's actually recover the column position of the basic square. So here, this one, I move to the next row position of the basic square. It's actually just recover it. And next is draw repeated patterns. Well, actually, draw repeated patterns like this. I draw this one, repeated patterns. It's actually this layer. and single pattern size equal to size divided by 3 actually, because like each of the repeated pattern consists of like 3 single pattern, and unit size equal to single pattern size divided by 4, because like each single pattern like consists of like 4 unit size. And yeah, it's really easy to understand. So here the same one, like the draw repeated squares, move to the next column position of the single pattern, and here I need to recover the column position of the single pattern, the next move to the next row position of the single pattern, and finally draw final pattern. Actually, draw final pattern is not the final one, because and it's just trying to combine all the helper functions I used before. Yeah, it's actually this one. So unit size equal to size divided by 16, because as this one indicates that there are 3 single pattern in a row, and each single pattern got 4 unit size, and there still are like 4 squares, and each have a 1 unit size, so it's actually 3 times by 4 plus 4 times 1. Repeated pattern size, of course, equal to size minus by like unit size times 4, and current coordinates equal to task position. Yeah, I use this one to combine 2 layers. I will tell this like next, and x coordinates equal to the first elements in the current coordination tuple, and the y coordinates actually equal to the current coordinate, the second elements of current coordination, and draw repeated squares equal to draw repeated squares first, and task pinup. So here I need to set the starting point of the draw repeated patterns by x coordinates plus 3 times s1 y coordinates. It's because of the starting point. Yeah, the starting point is actually the same. Uh, uh, Actually, the starting point here is this one. So I plus 3 unit size in the x coordinates make it like horizontally shift to this point, and horizontal and vertically shift down to this point, and I get the starting point of the repeated patterns. So finally, it is the final function that is draw integrated pattern of it is this one. So here there are like 6 arguments: handle, size of the final, size of the integrated pattern, color 1 for the first color 2 same, x coordinates, y coordinates actually different from this 2, because this is actually the Cartesian coordinates for the whole patterns, the starting points. Final pattern size equal to size divided by 4, because it's a final pattern size equal to size divided by 4, because this is a 4 by 4 pattern. So yeah, and task pinup set position to the starting point here, and pin down for I in range of 4, for j in range of 4. So task pinup. Here we also need to set the starting point of each final pattern. So I use a G as a row number, column number, and the I of the row number. And if I plus G mod 2 equal to 0, then it means it should print with color 1. And else it should use color 2. So actually I finished this. And here let's run some sample run. And task speed actually is the one I use to set the speed of the turtle to the fastest. And here draw a pattern, task 700, blue, orange. Can I, yeah. And this is the starting point. Let's try. So from here we can see it's just a draw like this. And it's while I'm doing this, you can see it's a roller. You can see it's well, it can be draw to the 4x4 easily. So I just stop demo here, and you can run um, by my code. There is actually a uh, little thing that is really strange because every like each first of the first of the square first row of square I mean first column of square will a little bit it's a like a 1 pixel like bigger than the other. I don't know why. And yeah, thank you for watching.